This is video number 5 in my series on desktop applications. This is a video application. It's a vanilla JavaFX application that uses the well-known GStreamer video processing library as its underlying video processing engine. This application is used in the context of security. It's the typical application you see where you have one or more security guards sitting in front of monitors where they see the output, the video output of one or more video cameras. It's based on the binaries from GStreamer. GStreamer is a well-known video streaming application basis. That is, it's a set of binaries for constructing video applications, and it's a JavaFX application. It runs the GStreamer binaries using JNA wrappers from this repository. Binaries come from the binary packages from the free desktop GStreamer, and we have JNA wrappers that you can obtain from this open source GitHub JNA wrappers, so we can call those binaries and use the binaries in our JavaFX program, where that works out that if you have a GStreamer terminal command, looks like this, then in Java, because you're using a playpin binary, you have a Java wrapper for that binary which you can call, so you can give it a URL. So here we are giving it a URI, and then we can play. So it's not quite as simple as this, but it's essentially the same. So there's a lot of complicated details that you need to deal with, but it's essentially as simple as that. Now, the wrappers from this repository, the video sync is actually embedded in a swing rendering component, and that caused a lot of problems. I don't know if it was because it was inside a JavaFX application, but it wasn't stable. So we rewrote it to use a JavaFX writable image. So it rendered, instead of rendering into a swing component, it rendered into a writable image or a JavaFX component, and that greatly improved memory usage and stability. This is the source code for the application. I'll just demonstrate the application now and then point out some of the more interesting features in the code. So we start the application, we're running it now from the main class, and so this is the application. It's got a number of layout options. So this is a 2-column layout, 3-column layout, and a 4-column layout. We can't really show the whole 4 columns easily in the available video screen size, so we'll go to 3 columns because we can comfortably show 3 columns. So now we can load up cameras. So we'll just sequentially go through the cameras and load each one. Some of these take a while to load. So these are actual public webcams that are streaming out there on the internet that I've wired up. But you would use local security cameras. So here we have a camera from Chile, Malaysia, and Vietnam. Some of these cameras will take a little while to come through. So just while the cameras are coming through, I'll pause the application and restart once it's picked up all the video streams from the other cameras. All the video cams have come through, so now we can show the relative stability of this application. So we can change between the columns, so it's fairly responsive. So we're moving from the 4-column view, 6 columns, 4 across, 6 cameras, 4 across, 2 here, 3-column view, 2 rows of 3, and a 2-column view. We can scroll down, see the bottom cameras, so now we'll move to the 3-column view, show some of the other features. So now some of these cameras support different protocols, but if they support the protocol that we've implemented in this application, when we select active camera, set it up so that you can use these sorts of controls. This camera doesn't allow you to change its view, so you can't pan its view. So we can see if we can pan it. No, it's refusing. So, but that's the idea of these controls, is that if the camera supports it, you can use it zoom in, zoom out, and pan around function. So now we'll just show the full screen. So I'll deactivate this one, activate this one because it's a nicer view, and go to full screen. So this is the full screen. You can also try and change the camera. So we'll try and change to a different camera while we're in full screen. So now we'll try changing, going back. It's not coming through. So we'll close. Deactivate it, it came through. So that's the idea. It's just your typical video monitoring for a security firm where you have a set of cameras, hook them up to this application, and then you can view them all simultaneously. And you have the options of full screen and the option, if the camera supports it, to integrate with some sort of control protocol. So now we'll just move on to talking about the interesting parts of the code. This is a JavaFX application, so it's a typical main class, it's a subclass of a JavaFX application class. Now the interesting part of the code is setting up the GStreamer binaries. So we have an app config. So in the app config, we have information about the cameras that we're working with and the URIs for the camera, so we can plug or pipe the streaming data from the camera into GStreamer. So we have that coming from properties files, and we pass that into this GStreamer handler class. Now the GStreamer handler class needs to know what is the architecture we're running on. Are we running on Windows? Are we running on Mac? Are we running on Linux? Things are a bit complicated on Windows. First we need to determine are we 32-bit or 64-bit Windows, and then sometimes GStreamer needs an environment variable, so we could set the environment variable with this project CanI, or we can also set the system property, have this idea of an environment variable or a system property for the JNA library path, and the JNA library path needs to point to where the GStreamer binaries are on the Windows system. Now Unix is almost trivial in comparison. Probably a good idea to run on Unix when that option is available. Now that we have our GStreamer binaries plugged into our system so we can use them with the JNA wrappers, we have a video player package, and this is our video player. Now the video player, the way it's set up with the JNA package structure, there's this idea of a video component. This video component is going to wrap our GStreamer binary wrappings. So the primary one that mainly gets used is this idea of a play bin. And a play bin is a GStreamer artifact that can handle automatically a whole bunch of video codecs. So when you use GStreamer, you can use a specific GStreamer artifact for a specific video format or codec. So it can be what's called HAL. There are a bunch of video codecs. Playbin has a whole bunch of them, so it can sort of automatically adjust itself. It can sense what is the codecs in the video stream, and then sort of somehow magically it figures out what is the correct decoder to use for the video stream. So most of the time we end up using this binary artifact that's wrapped in JNA called the playbin. Get our playbin, and there's a bus for the playbin. The bus allows us to figure out what's happening on with errors, so we can deal with errors, and this playbin is wrapped in our video component, and our playbin has a video sync. Now the video sync, when the video stream comes in, it's in a coding format. So our playbin will figure out what is the decoder and decode that stream in such a way that we can render frames. So it wants to pass it into a video sync, so that is the place where we render the frames, and that's wrapped also in a video component. Go now to our video component. You can see our video component has this RGB data sync. So this video sync, this is the place where we're going to render the frames. So if we look at the renderer that our video sync is going to use, here is our renderer. This extends an image view, so we could plug this into the view. So when we're looking at the camera display in the application, it's an image view, and that image view is going to render the frames as an image sync. And if we go down the bottom here, we can see we're actually doing that frame by frame, rendering the frames. We're using this writable image as our sync. So we've got this writable image, and then we have a whole bunch of frames, and then this whole component here is extending image view. An image view needs an image, that's our writable image, and our writable image will have a particular frame. And then we just, for each frame that's coming in from the video stream, we update our writable image with that frame. So that's essentially how it renders the video, and it's using the JavaFX writable image. Now, if we look at the code, just come back, File, Reset. If we look at the JNA wrapper package, so this is the JNA wrapper package, the JNA wrapper for GStreamer. If we look in this package, and we could see it has a swing, and it's got a swing video component. So this is like a swing analog for the code that I just showed you. Here we are doing this, what the JNA wrapper does. We've updated that to use JavaFX code for the rendering, and the particular rendering artifact we're using is this JavaFX writable image. Now, if you use the original GST Core swing component, we found that when we were developing this application to be very unstable. Now, I'm not sure if that was just because we're using swing inside JavaFX, but it seemed to really improve things greatly when we moved over to rendering the frames in JavaFX. All of a sudden, the application became much more stable, used much less memory, so we're able to deal with many more cameras. So that's basically the interesting part of the code. The rest of it's just UI layout, JavaFX widgets, laying it out, a GUI that's responsive. It's got some events, it's got some buttons, but really what's interesting is the way this code binds the GStreamer binaries via JNA wrappers and renders the actual video stream.